Our brain makes painkillers. In fact, our brain and brain stems are one of the most prolific drug dispensers around. But as with all drugs, there are unwanted effects at times, and the most powerful ones tend to have an effect that requires ever more drugs to do the same effect. So one prominent class of these painkillers we make is opioids, including enkephalins, dynorphins, and endorphins. Opioid chemical receptors are found throughout the nervous system, in the brain stem, and the spinal cord. A synthetic drug that activates these receptors is morphine. Serotonin is another chemical involved in pain, but it's much more complex since it both decreases and increases pain perception in the brain depending on where it acts, and it increases pain from the body. Another interesting note is that our gut makes considerably more serotonin than our brain does. Antidepressant medications that recycle serotonin, the SSRIs, seem to help some pain conditions like fibromyalgia by influencing that serotonin. Adenosine is another one. It's not a popular chemical, but interestingly, caffeine actually blocks the effect of adenosine. Of course, caffeine also keeps most people awake. In rat studies, caffeine reversed or blocked the pain-producing effects of sleep deprivation. Nitric oxide, often used as a supplement, especially for improved blood flow, has a complex spectrum of effects on the body. It produces smooth muscle relaxation, vasodilation, resulting in slowing of heart rate and lowering of blood pressure. So while blood cells are also used to kill invaders like handheld laser guns. So nitric oxide seems to inhibit the production of chronic pain in the nerve bundles just outside the spinal cord called dorsal root ganglion. All right, inflammation causing or suppressing chemicals. That's what we're going to talk about now. And we start to enter the world of inflammation. Ongoing low-grade inflammation is thought to increase the risk of a number of chronic health diseases, including heart and blood vessel, diabetes, neurodegenerative like Alzheimer's and neuropathy, and chronic pain conditions. So it would seem logical that we want to get rid of inflammation, right? Yes, but it might be helpful to think of inflammation as the automatic sprinklers in a building on fire. Leaving them on all the time is clearly a disaster, but never having them on strong enough to put out the fire is even worse problem because then you have both the fire and the water damage. So that's how chemicals related to tissue damage, the fire, and pain and inflammation, the water sprinklers, work in harmony. So let's use this cool little graphic. You guys can see this. All right, so we have sprinklers at the top, inflammation and pain, tissue damage down here. Tissue damage causes a reaction, a tissue reaction. Inflammation and pain sprinklers turn on in an attempt to resolve this and avoid further damage. Interestingly, the tissue reaction itself is it's also like a sprinkler. So prostaglandins is our next chemical. This set of inflammatory markers is a classic strongly related to pain and fever and blocked by NSAIDs like ibuprofen and aspirin. As recently as 2019, researchers were just discovering that these prostaglandins not only promote inflammation, but they also help resolve it. So blocking its function with regular use of ibuprofen or aspirin may be counterproductive, leading to a state of chronic inflammation and pain. So back to our little picture. If we have an adequate response to the tissue healing, to the tissue damage, then the tissues will heal. Inflammation, pain, and tissue reactions subside. All things are good and everyone's happy. But if there's an inadequate response, the fire of tissue reaction, irritation, inflammation, pain may continue to smolder like a fire that never gets put all the way out. Cytokines are another classic group of chemicals related to pain. You may have heard of interleukin 1 or 6, or the scary named tumor necrosis factor alpha, for short TNF-alpha. Interleukin 6 is a small protein made by white blood cells that seems to amplify pain. But remember that prostaglandins also seem to resolve inflammation. Pain for a moment, but pleasure for a long time. Cortisol, the The hypothalamus, which we fondly know as the hypothalamus, activates the adrenal gland to release cortisol, similar to synthetic cortisone or prednisone medications. For those of you familiar with this, this is the HPA axis, or hypothalamus pituitary adrenal axis, that results in cortisol release from the adrenal gland, which we often think of as a response to stress. Cortisol inhibits pro-inflammatory chemicals called cytokines. Those cytokines promote pain, so cortisol decreases pain by reducing cytokines release. Sounds good. Well, chronic pain conditions like rheumatoid arthritis, fibromyalgia, headaches, and low back pain show dysfunction in this HPA axis, resulting in excess or deficiency of both cortisol levels and HPA reactivity. The higher baseline cortisol alone might seem to promote a decrease in pain, right? Because cortisol decreases cytokines and pain, but the excess in the system, known to suppress, it suppresses immune and inflammation responses. That seems to actually cause higher pain sensitivity when it becomes chronic. So perhaps it is preventing the normal healthy inflammation response and the resolution and calming of the response, which we thought about in our picture here. Recall that the inflammation response has trouble finishing its job also when someone is taking NSAIDs for pain. Another chemical, melatonin, a chemical released by the pineal gland in the brain. Melatonin regulates inflammatory chemicals like prostaglandins and cytokines, both known for their pain sensitizing actions. And melatonin is released when we are in the dark, when we're sleeping. The next one is endocannabinoids. That's our last chemical class. We make some, including anandamide, which is easy for me to say, right? Anandamide. But most of the research and even more sales is related to cannabis, both THC and CBD. Cannabis reduces pain, but increases psychological distress. Little is known about the long-term use. Alrighty, that's it for a dive into brain chemistry today. So what are some good takeaways? Well, brain inflammation and pain chemistry is complex, more than we know even. Medication effects are usually incompletely understood, at best, by the manufacturers and prescribing doctors. Take as much medication as you have to and as little as you can. The most important takeaway, supporting the normal process of pain and inflammation may be the most effective way to get rid of it. This series is about how to support it and resolve it with proper nutrition, thoughts, emotions, and movement. Start by applying some of these principles today. If you'd like help, give us a call or go online and set up an appointment. Have a wonderful day, and may God bless you.